Hello everybody, my name is Akhil and in this video we are going through the day 9 challenge of the lead code. If you are unfamiliar with this challenge, this is a 30-day lead code challenge and we are given a problem every day at a specific time, and today's problem is the backspace string compare. So in this video we are going through this problem, and I'll explain the basic solution and also the follow-up, and we also talk about the time and space complexities along with the optimizations. So basically I will read out this question first. We are given two strings s and t, and the backspace character, so the hash character is considered to be a backspace character. So whenever we encounter a hash character, uh, we have to remove the previous character. So we had to do this for both the strings and have to return true if both are same at the end of the computation, and return false if they are not equal. So the easiest approach or the brute force solution could be this. We can use a stack, and whenever we find a character we can just insert into the stack, and whenever we find a hash character we can pop out the topmost character. In this way we can obtain the uh, final computation of the string, and we do that for the both of the strings, and check if it is true. So okay, we can start off by defining a function which takes in a string s. So basically after that we define a stack. We can just simply use a list to do the task, and for x in s, if we have a normal character, that means f is not equal to hash. That means we just have to append the character, I mean pushing it into the top of the stack, which is just this. And else if we have, if x is equal to string, I mean hash character, and we have the stack as well. So if the length of the stack is 0, we should not attempt to pop the element, right? So that makes sense. And then finally return, we just have to return what is the output that is present in the stack, right? So this need not be the correct string, but which will generate the same thing. If it has to be true, then it obviously returns either the ascending order or in the reverse order. So we return function of s is equal to function of t. So I think this should work. We'll check that now. Yes, it's accepted. So we'll come to the space and time complexities of this solution. So basically we have a function which will pass through the entire string. So this should be the time complexity of t of n plus m, where n is the length of the first string and m is the length of the second string. And we also have the space complexity of, since we are using a stack, the at most space we have to be using is order of n plus m in both the function calls. And there is no recursion here, so we don't have a function, so we don't have a recursion stack. So this is basically considered as an order of n time and order of n space, and this is not the most optimal solution we can obtain. Here the follow-up, so we are done with the solution. We can also do optimizations. The follow-up for this question is, can you solve it in order of n time and order of 1 space? So how can we eliminate this stack space? If we remember very well, in this approach we are parsing the string from left to the right, and whenever we are encountering a hash character, we have to go back or pop it from a stack. So we have to if we go in this approach, we have to be coming back to the previous characters as well. So to optimize this, to optimize the space, the simplest solution could be to parse the string in the reverse order. That means if we have if we consider this example, how can we obtain AC from this solution, from this string? So we go back and we start at this character. So since this is not a hash character, we can directly consider that into the output. We can append that into the output. Then we find the hash character. That means we should not consider the next character. So we can decrement the I by 2, right? And then we can come to A, and this is not a hash. So we just append that to the solution. This is the simple way of explaining the upcoming solution, and we do the same for this. So we obtain AC in both the cases, so we get true here. But what about if we have a hash here, and if we skip 2 characters to the front, we are missing this hash, resulting in A as the output. So we have to consider multiple hashes being together, right? So what we do here is we start exactly, we do the parsing exactly like in this case. What we have to add extra in this case is that we start from this character, and since this is not a, since that is a hash character, we increment the count of hashes by 1 and come to the next character, right? In this case, this is also a hash, so we have to increment the number of hashes. We keep a counter variable that just has the account of how many hashes we have encountered till now. And so here we have the number of number of hashes count as 2, and then we come to the B. At this point we are at B, and then here what we have to do is, since this is not a hash character and the count is greater than 0, we just have to decrement the count by 1 and not append this to the solution. And then we come to A, and now the count is 1, and this is also not a hash character. So what we have to do here is decrement the count by 1 and don't consider this to be a solution. So finally we don't have anything in the output string, we just have a null string or an empty string, right? We do the same thing here. We start from the last hash and then increment the count by 1 and come to the D. Since this is not a hash character, we just decrement the count by 1. When we decrement the count by 1, it means that we are not considering the character. So we decrement the count by 1 and ignore this character and does not add this to the output string. So again we come to here, and in this case we have the count is 0, count of the hashes as 0, so we just increment the count by 1 and we again come to the C character, and since the count is 1, so we have to decrement it by 1 and ignore this character. So in this case, in this example, we have the output strings for both the S and T as empty strings. So since 2 empty strings are equal, we just return the true. I think the solution is very clear, and in this we are not utilizing any extra space other than the count variable, right? So also we are parsing both the strings only one time. So the time complexity is order of n plus 1, n plus m, which I think this should be wrong because it should be order of n plus m, and this is very crucial because always the time complexity will not be in terms of n alone. We have multiple inputs, so we have to consider that as well. And the space is, we are just using the counter variable, and that doesn't come under the order of n or m. So it is order of n plus m solution and order of 1 space. So we just start typing that out and we'll see if this works. So we have a function which will take a input as a string, exactly as how we have defined in the previous solution. And what we have to do here is we have to have the count as 1, and we have to start at the end of the string, right? So n is equal to length of the string, and then we have to see whether we have to do all these operations only while the I is greater than or equal to 0, right? Only then it is valid. So then what we have to do is, if count is equal to 0 and and if the string, if s of I, so what we have to do here is, so s of I is equal to hash, we just increment the count by 1. Sorry, so we have to consider the case in which we have to add the character to the output. So if the count is 0 and if the character is not hash, only then we can add the character to the output. So we can say that result is equal to null string, and result plus is equal to s of I, and then we have to decrement the I by 1. So okay, and then else if count is greater than 0 and s of I is not equal to hash. In this case, what we have to do is decrement the count by 1, right? So if the count is greater than 0, yes, count has to be decremented by 1, and also I has to be decremented by 1. Else if count, so what is the case that we have left out? If the count is 0 and s of I is not equal to hash, so also if the count is equal to 0, okay, else if s of I is equal to hash, so that means we are encountering a hash character, we have to increment the count by 1 and also the decrement I by 1. So now we have to return the result, right? And then in the main function we have to just return the function of s is equal to function of t. I think this should make sense, and we'll just try running this code. So okay, so we have not defined what is, or we have not initialized I. So this gave true. We'll check submitting this. So have we left out any other case? Count plus is equal to 1, and if count is equal to 1, result is equal to return this. So we had to check what has been wrong here. So we have a hash character, okay, while I is greater than or equal to 0, we have to see s of I. Okay, if count is equal to 0, yeah, the only mistake we have done here is that it should start from the back, right? We'll try running now. Accepted. So so the time and space complexities of this solution is, the time is order of n plus m. Note that this is not order of n solution, it is order of n plus 1. This is very crucial when you are appearing for interviews, because the specificities and make the interviewer feel that you know things and you know what you're doing, and this is order of 1. That's it for this video, guys. Thank you for watching. If you have liked this video, please share and subscribe. Thank you.